Welcome to College Algebra, Section 1.1, Part 2. I'm Gregory Carlson. Let's pick up where we left off. Our next problem is a fraction problem, which always seems to cause people trouble, but luckily they're not so bad. What I'm going to do in this problem, normally what I would do here is I would go ahead and multiply as the first step to cancel the 3 and the 10 in this problem. However, let's do this a little differently. Let's go ahead and distribute this 2/3 with the distributive property just to practice multiplying fractions a little bit. 2/3 times 7, remember this 7 is in the numerator, and so that means 2 times 7 is 14. So this would be 14 over 3g off to the side. The g is also in the numerator. Minus 2/3 times 1 is just 2/3. It is very important that you download and write all these steps down as I'm doing them. You're not going to learn very much just by watching me do it. It's really a good idea to get your hand in the motion and do this actively yourself and think about it as we go. So I encourage you to write these steps down for your notes as we go. All right, so we've got an equation with fractions, and the best thing to do at this step is to go ahead and multiply by the least common multiple of these numbers. In other words, the smallest number that we can think of that has 3 and 10 as factors. And so if you know your tables, multiplication tables, this is pretty easy. The number is going to be 30. So we're going to multiply the entire equation by 30. And when we do that, we need to multiply every term by 30. And so what I like to do is write a 30 above each term. And that way I know that I'm multiplying with the distributive property and multiplying every term by 30. So in the first fraction, 30 cancels with the 3 and becomes a 10. And so that means the 3 is gone, so I have 10. Remember, we're multiplying here. So I have 10 times 14, which would be 140g. Here I have 30 and 3 on the second term. So 30 cancels with 3 and becomes a 10. So that means I have 10 left over. 10 times 2 is 20, so this will be minus 20. On the last fraction, I have 30 and 10 canceling. With the 10 canceling, that means I have 3 left over. Now you see I have tons of stuff up here, g plus 3. That means what I need to do is write 3 and then g plus 3 in parentheses, because we're going to need to multiply the 3 times all of that. So we know we've done this correctly because we have no fractions left. That was the whole idea of multiplying by the least common multiple. Now, if we wanted to, we could have multiplied by 30 in the previous step. And if we did that, I would have had 30 canceling with 3. And that would have given me 10. And then 10 times 2 is 20. And then when you do the distributive property, you get right here. So with all of these equations, there's more than one way to get to the answer. I would do what feels most comfortable for you and what you can do consistently. So let's finish up with this equation. Let's multiply the 3 with the distributive property. So leave the left side alone because it will not simplify. 3 times 3 is 3g, and 3 times 3 is 9. Next, let's get all of our g's to one side. I'm going to choose to subtract 3g to keep things as positive as possible, which will give me 137g minus 20 is equal to 9. Let's rewrite that where we have a little bit more room. That's 137g minus 20 equals 9. And let's next go ahead. We want to get g isolated, so let's add 20 to both sides. Hopefully you're doing this on your paper as well. 137g equals 29. Divide by 137, divide by 137. And so we get a final answer of g is equal to 29 divided by 137. And it's a good idea to leave this as a fraction because that's the exact answer. If you convert it to a decimal, it's only going to be an approximation. This fraction won't reduce, and let's just make sure of that. Let's do 29 divided by 137. And we get this crazy decimal, and so that's not going to simplify. What I'm going to do now is let's go ahead and check our answer, and let's use our calculator to help us with this. And one of the questions I always get is, Mr. Carlson, how many decimals should I put down? And the answer is you should put down a lot of decimals, because if you round in a problem too early, you can multiply that rounding error until you get to a place where you don't have the right answer. So let's be very careful and use 29 divided by 137 to check our answer. First, let's see what we get on the left side. So again, my answer is 29 divided by 137. This is the answer I get. So on the left side, order of operations, multiply by 7 first, so times 7 equals. Now let's subtract 1. I just hit -1 equals. Your calculator should probably do the same. And so I'm keeping as many decimals as possible. Now how do I multiply that by 2/3? Because I can't type in 2/3 into my calculator. Well, we can just times this by 2 and then divide it by 3. And that's the same as multiplying by 2/3. So times 2 equals, divided by 3. And I get the following decimal on the left side, 0.32116788. Do you see how I was really careful and I wrote down a lot of decimals? We're mathematicians. We want to be exact. We don't want to round if we can avoid it. So let's see what the answer is on the other side. I'm going to clear it. And I have my answer of G, so let's plug that in again. 29 divided by 137. And there's my big long decimal again. So over here, let's do G plus 3. So we'll add 3. And I get this, so that's the total numerator, and divide it by 10. And look what you get. You get the decimal 0.32116788. Do you see how I was very, very careful and I kept all the decimals in my calculator as I went to get the answer on both sides? That's a skill you'll want to be able to learn so that you can do it yourself, because that's how you can be very confident that the answer is correct. Even on a very strange answer with a lot of decimals, we can find the correct answer and be confident of it if we're very careful and precise. Let's wrap up these equations. We have a few more left to do. Here's our next one. 4 times 3x minus 8 equals 2 times 6x minus 16. If you're feeling confident, pause the video and see if you can do it on yourself. I'll wait. Go ahead, pause the video. All right, let's see if you got the right answer. Do the distributive property on both sides. 4 times 3x is 12x. 4 times -8 is -32. On the other side, 2 times 6x is 12x. And 2 times -16 is -32. At this point, you should notice I have the same thing on both sides. 12x minus 32 equals 12x minus 32. That should tell you something. In fact, you could stop there, but let's go ahead and move all the x's over. And they cancel. And we get -32 is equal to -32. That's the same thing on both sides. However, the numbers match. Unlike last time, where the numbers, we canceled all the x's, but the numbers didn't match, which meant no solution. Here, -32 is always equal to -32. In fact, that's called an identity. And so that means that the solution is all real numbers. Any number that we plug in for x will be a solution. And so all real numbers is the answer. You should go ahead and try that. Plug in a bunch of different numbers, -2, a billion, 0. They should all work. And so the answer is all real numbers. Now, what does real mean? A real number is one that doesn't have a complex part or doesn't have an I part. We'll talk about that later, and so don't worry about it for now. The last one we got over here is, well, not the last one, but 6x minus 10 is 0. Don't get thrown off by the fact that one side is a 0. Let's add 10 to both sides, which will give me 6x is equal to 10. Divide by 6, divide by 6. And so I get x is equal to 10 divided by 6. That one wasn't too bad. Here's an example of one you should keep as a fraction because it has an infinitely repeating decimal. You should reduce the fraction, however. Some math teachers will take off a half point if the fraction's not reduced. So I notice they're both even, so 2 goes into both of those. Divide the top and the bottom by 2. And so I get x is equal to 5 divided by 3. So that's the answer, x equals 5 divided by 3. You could convert that to a decimal, so let's do that. 5 divided by 3, and you get 1.66666. So if we write x and 1.6666 and then maybe a 7, you should put an approximation sign, which is like a equal sign, except it looks like this. It's an approximation symbol because x is approximately 1.666667. It would be better to write x is equal to 1.666 and a bar over the last digit, because that means that's an exact number. X equals 1.666 forever. So, or you could just avoid all of that by just keeping it as a fraction, which is what I would recommend. We have 3 more problems to do in section 1.1, and I'm past the 10-minute mark, so I will see you in part 3.